Hello guys, welcome back. In this video, we will be discussing the first principle of derivative. In the previous video, we talked about the basic definition of derivatives. So going by that discussion only, we will be describing the first principle of derivative. So in the previous video, we discussed the basic formula for calculating the derivative. So for starting with the first principle of derivative, we will be considering a function first. Let's say f of x, which is a real valued function. So this is the real valued function, and the derivative of this function by the first principle of derivative will be f prime x, which is equal to limit h approaches 0 f of x plus h minus f of x over h. Now if you remember, we were calculating for a specific point like f prime a. So we were calculating like f prime a is equal to f of a plus h minus f of a over h. Limit h approaches to 0, of course. So this here is like a general formula. So it is for any general point x. So this is f prime x, which is the derivative of f of x. Right. So this is the formula for the first principle of derivative for calculating the derivative of a function. So this is the formula which we will be using in our future examples. So if you are differentiating to basically first principle, right? Now some notations are there. This f prime x is a notation for the derivative of f of x. Similarly, we can write this derivative as d by dx of f of x. So this is another way of writing a derivative. This d by dx is the derivative operator, right? So this is the derivative operator. So now let's say f of x can be also written as y. Let's say fx is equal to y. So this derivative can be written as dy by dx. So this is also just another way of writing a derivative. If we can assume this f of x is equal to y, right? So these were some notations of writing a derivative, basically mathematically, right? So, okay, so now let's take an example for calculating the derivative of a function with the help of our first principle. Okay, so let's see an example. So let's say our example is we have to compute the derivative of y is equal to f of x is equal to sin x by first principle. Okay, so now let's evaluate this. So what was our first principle? It was f prime x is equal to limit h tends to 0 f of x plus h minus f of x over h. Now remember, this limit should always exist in order for this derivative to exist. So this limit should exist, right? So now what is f of x plus h? So we will substitute x plus h in this function, so that will be sine of x plus h minus sine of x and over h. So now we have one identity, that is sine of a plus b is equal to sine a cos b plus cos a sine b. So let's expand this sine of x plus h. So that will be sine x cos h plus cos x sine h minus sine x over h. Okay, so now let's try to take something common and rearrange in a better way to compute the limits. So when we take this minus sine x as a factor, this is minus sine x 1 minus cos h, and this is cos x sine h. right? And this all is over h, right? So now this 1 minus cos h can be written as 2 sine square h by 2 by the identity 1 minus cos 2x is equal to 2 sine square x. So we can easily substitute that here, right? So that will be 2 sine square h by 2 over h plus cos x into sin h by h. So by the algebra of limits, we can write it more clearly. So by the algebra of limits, we can substitute limit in this also and this also. So we can, let's make this more clear here. So we can write this as limit h approaches to 0 minus sin x, that this is 2 by h, and we can write this as sin h by 2 over h by 2 whole squared, and this also gets multiplied by h by 2 whole squared, plus I am splitting the limits also by the algebra of limits. So this will be limit h tends to 0 cos x into sin h by h. Okay, this sin h by h, limit h tends to 0, this sin h by h is equal to 1. So this part will be cos x, right? So this will be cos x plus limit h tends to 0 2 by h multiplied by h square by 4 times limit h tends to 0 sin h by 2 over h by 2 is also 1. So this will become like, if we evaluate the limit, so this will become sin h by 2 over h by 2 whole square. So this will be equal to 1 when we evaluate the limit. And the final thing will be, it will be cos x plus limit, so we can take help of the previous steps, this thing will be h by 2, right? So and this thing will be 1. So this will be limit h tends to 0 h by 2, right? And now limit h tends to 0, h by 2 will approach to 0. Since h approaches to 0, so h by 2 will also approach to 0. So the final answer is coming as cos x. So that means f prime x is coming as cos x, right? Hence this is the derivative of f of x is equal to sin x, that is cos x, by the first principle of derivative. So this is our answer. Guys, one thing that I forgot in between, that is minus sin x is also getting multiplied over here. So that will be, this thing will be multiplied by minus sin x also. And let me write it better. So in the final step, this thing also gets multiplied by minus sin x. Okay. But since this part is getting 0, so our answer won't be affected, right? So our answer is again f prime x is equal to cos x, right?